Right. In this recording, I'm going to try to kind of help you get started on how I want the forms filled out for your functions toolkit, and it'll help if I get the correct form up here. So hang on a minute. Nope. Okay. Taking a look at the linear functions. There we go. First thing you're asked for is the most used general form. There are several different forms for a linear equation, and I'm kind of looking for you there to think about the one that you think is the most useful. Certainly it depends on the problem, but what I think about here is the form y equal mx plus b. So that's what I would put in the most used general form section. Now when you look at that equation, the m and the b are what we refer to as parameters. So in the second part of this sheet, I want to talk about how different values of m change what the graph of the line looks like, and how different values of b change what the graph looks like. So let's think about slopes. You can have a slope that's positive. And what does that do to the line? If the slope is positive, you know your line is increasing. So I would write that. Sketch it and write it to be very, very clear. You can have a slope that's negative, and if that's the case, then you know your line is decreasing. And the other option is that your slope could be equal to 0. If that's the case, you know you've got a horizontal line, which makes the function constant. Okay, now we're also supposed to talk about where the function's concave up, concave down, whether asymptotes and lines don't have concavity. So we don't have anything to address there. So next, looking at the second parameter, the value of b, the y-intercept of the function. There are three possibilities for b. You could have a value of b that's greater than 0. Okay, and if that's the case, your graph crosses the y-axis below 0, or below the x-axis. You could have b that's, oops, wait, let me fix that. That's not right. If b is negative, the graph crosses the y-axis below 0. If b is positive, then you know you've got a graph that's going to cross the y-axis above 0. And then, of course, if b is equal to 0, then your graph is going to cross the y-axis at 0. And I missed there. Okay, so at the point 0, 0. Now, since you're specifically asked to talk about concavity and asymptotes in this section, make note that you're actually doing that. Linear functions have no concavity and no asymptotes. Now, of course, what you do that you would turn in to me is going to be a lot neater and better organized than that. But that's giving you an idea. You want to be very as specific as you possibly can in the graph and parameter roles section here. All right, and then thinking about domain and range. And you can actually look at the sketches you've drawn above to kind of help you think about domain and range. Domain for any linear function is all real numbers, always and forever. Range is usually all real numbers, except for the situation where the slope is equal to 0 and you've got a constant function. Then you're only going to have one value in the range if that's the case, looking at this section right here. So except when the function is constant, or you can say slope is equal to 0, then the range is just the value b, the y-intercept. Now, special terms. We've used words like slope, y-intercept, okay, those are the two that come to mind quickly. Make sure that you remember to define those terms. And if you've already filled out the vocabulary section in part 1, chances are good you've got definitions for any of the special terms that you're going to come across. Then the very last section of the sheet where you've got other forms, that's your opportunity to list the other forms of the linear equation. The general form, and it's a good idea to label it. The slope-intercept form. Okay, and any others that you run across. There is something called an intercept form of linear equation that I've seen places, but the two that I would definitely expect to see, there are 3 basic forms of the linear equation that I think about. General form, slope-intercept form, and I labeled that wrong. That second equation there is not the slope-intercept form. That's what we started with. This is the point-slope form. There we go. So the three forms of the equation: general, point-slope form, and slope-intercept form. So the point is that you want to be as specific as you possibly can be and be very, very thorough. Basically what you're doing in this project is kind of outlining everything you know about these types of functions. So when we're working with linear functions here, you need to sort of in some way or other describe everything that you know about a linear equation. As always, if you're working on something and you need some help or have some questions, all you've got to do is ask. Let me know and I'll be glad to help you out.